Let's dive right into this explainer and see how we can take some incredibly simple programming concepts and assemble them into actual real-world applications. If you've ever looked at a wall of code and felt totally intimidated or just wondered how a basic text file magically becomes a working program, you are absolutely in the right place. Today, we're taking a structured journey. We're going to start with the absolute basics of Python programming, and by the end, we'll be looking at the blueprints for some really impressive interactive stuff. We're stripping away all that confusing jargon, and we're just going to focus purely on the core tools you need to bring your ideas to life. Here's our roadmap for this explainer. 1. Setting up your workspace. 2. The basic building blocks. 3. Logic and adventure games. 4. Calculating with loops. And 5. Managing complex data. Let's just jump right into step 1. Section 1. Setting up your workspace. Okay, so just like a carpenter needs a solid workbench, you need a coding environment. And we build this in 3 super fast steps: getting the language, getting the editor, and getting the extension. First up, you grab the actual Python language straight from python.org. You can think of this as the engine of your car. Next, you need a comfortable place to actually write your instructions, right? So you install a free text editor like VS Code. Finally, inside VS Code, you install the Python extension. That extension bridges the gap, letting your text editor seamlessly talk to the Python engine you just downloaded. It really is that straightforward. Now, before we write a single line of code, let's get real for a second and set our expectations. Making mistakes is a totally normal part of the process. Seriously, do not freak out when things break. Even the smallest missing character, an extra space, or, a forgotten quotation mark is going to cause your program to completely halt. Computers do exactly what you tell them to do, down to the literal keystroke. So when an error pops up, the computer isn't judging you, it's just asking for clarification. Being really thorough is your absolute best defense here. Moving on to Section 2, the basic building blocks. First up in our tool belt is the string. This is our go-to tool for handling text. Whether you type a word like hello, a full sentence, or honestly even just the number 4 inside those quotation marks, Python treats it all exactly the same, as a string of text characters. It's essentially the primary way we communicate back and forth with the user. Next, we have the integer. This is our data type for counting whole, non-decimal numbers. So if you're trying to track a score in a game, count the items in a shopping cart, or even use a negative number for a penalty, the integer is exactly what you want to use. But what if you have a decimal? Even if it's just 0.0, you are now working with what's called a float. Floating point numbers give us that necessary precision. You're going to use these anytime you're dealing with money, exact measurements, or any fractional math where just rounding to a whole integer won't cut it. And finally, we have the Boolean. This simply evaluates if something is true or false. And, a quick heads up, in Python those keywords actually have to be capitalized. Booleans are essentially these tiny invisible switches running inside your code. Like, is the user logged in? True. Is the game over? False. These true and false statements dictate exactly how our programs flow. Which brings us perfectly to Section 3, logic and adventure games. Pay close attention here, because this trips up pretty much every beginner. Let's look at these 2 common hurdles side by side. One stores data, and the other asks a question. When we use a single equals sign, the assignment operator, we're taking a piece of data, like a player's name, and storing it in a bucket, called a variable. But when we use the double equals sign, the equivalence operator, we're not storing anything at all. We are asking a Boolean question. Does the value on the left exactly match the value on the right? So, using these conditional tools, we can check if a user typed left or right and branch our adventure game's path based on that. By wrapping our equivalence operators inside if statements, the game literally wakes up. We can say, hey, if the user's direction exactly matches left, print you fell off a cliff. Elif, which is just short for else if, the direction matches right, we present them with a bridge. And else, which just catches absolutely everything else, we print invalid choice. Boom! You've just created an interactive tree of branching possibilities. Let's level up in Section 4, calculating with loops. Now, a crucial thing to understand is how Python actually handles math. Your standard addition, subtraction, and multiplication, they work exactly like you'd expect. The exponent is just a double asterisk. But look really closely at division. Even if you do a simple 4 divided by 2, Python outputs a 2.0 float, not a whole integer. And that percent sign, it's called the modulus operator. It does not calculate percentages, it actually gives you the remainder left over after a division. Kind of a quirky one, but super useful. Of course, encountering an edge case, like, say, trying to divide by 0, is totally normal. Fixing it is just part of the process. If a user types in a 0 for the second number in our calculator app, you're going to get a zero division error, and the whole program just crashes. As a programmer, your job isn't to write perfect code on the first try. It's to anticipate these exact edge cases. We can easily just throw in an if statement to check if that second number is 0 before we even attempt the math. It effectively bulletproofs the application. Now, what if we want to continuously ask a user for a valid number without our calculator crashing? We can use a while loop, combined with try and except blocks to handle those errors graciously. While loops are amazing for uncertainty. You're basically saying, keep running this block of code while this condition remains true. That is perfect for prompting a user over and over until they stop mashing letters and finally give you a real number. Contrast that with for loops, which are built for certainty. If you know you need to do something exactly 10 times, a for loop paired with the range function is your fastest, cleanest tool. Finally, let's bring it all together in Section 5, Managing Complex Data. Storing a single name in a variable, that's easy. But what happens when you need to store a name, an age, and an email for hundreds of different people, and you want to search through them instantly? That's why we use dictionaries for something like a contacts app. Instead of memorizing random list index numbers, we can just look up logical keys. A list is great for storing items in a very specific order, like a top 10 leaderboard where you access them by their position number. Oh, and side note, in programming, we always start counting at 0. But a dictionary, it pairs a key with a value. So to find someone's email, you don't ask for the data at position 2, you just ask the dictionary for the value attached to the key called email. It makes your code incredibly readable and super efficient. Just think about how far we've come with these basic concepts. We grab strings of user input, we bundle that into a dictionary that represents one single person, and then we use the append method to push them into a massive list of all our contacts. Need to remove someone? Just use the pop method. And because we definitely don't want all this data vanishing into thin air the second we close VS Code, we translate our Python list into JSON, which is a standard text format, and save it permanently to a file. You now have the foundational blueprints. We've covered everything from setting up your environment and understanding simple data types, all the way to routing logic, iterating through math, and storing complex data structures. The true beauty of Python isn't just knowing these syntax rules. It's how you combine these simple building blocks to solve actual real-world problems. I highly recommend taking these blueprints, opening up your editor, and experimenting right now while it's all fresh in your mind. So the only question left is, what amazing piece of software are you going to build next? Thanks for hanging out with me for this explainer, and happy coding.